surprised how many methods you can run with the same equipment.
Yeah, yeah.
And you can get different electrical parameters, like not only the current or conductance, but also resistance, capacitance, electronical parameters.
Right.
Yeah.
And so for each of these things, you basically get these profiles, and they I
Yes.
see are they like CSV files, or you can download the raw data in some
So you
format?
could have a text file, you can have CSV file.
Yeah.
Also, there's another kind of file I can share with you, the original one, saved by file. But I was able to open those using Python code. I could share the code as well.
Yeah. I mean, if I get the pure text file, then I can start working on the big data analytics stack, right? So we may have to convert this into like a simple library to ingest it and put it in some.
So ethanol is evaporating, not possible to measure actually. We will measure your control.
Let's measure the finish control, you know.
Where is the control?
Here it is.
Okay, here it is. And how can I take it? Maybe, like this we take?
Yeah.
For the next
That's
time.
fine. Yeah.
We could have a...
It's contaminated.
It should not be that much. Can you do...
You can't? Or?
I think it's better
Can I
to...
use this?
We can just, if that's clean, use it. I don't.
Yeah.
Sure.
Take a bit. Can you apply just tiny bit and make sure it doesn't go to the contact zone? Just small drop. You don't have to put it back, maybe you can do it.
It's fine.
Where?
On this contact zone like I
Black.
did before. Yes, the area of carbon. Yeah, one more. Yeah, you see? Can you do one more drop? Thank you so much for helping me. Lovely, now we measure. Okay, fingers crossed for this.
Then we'll decide, very less alcohol compared to that one.
Oh, I don't know.
But how much is whiskey, the alcohol percent? I think
45? What is it?
43.
Okay, there's something, okay. How this happened, not sure, but it happens time by time. The channel, the another cable is connected. So we want to have channel 0 instead of 1, because these are two channels. One is named 0, another one is 1.
Yeah.
And that's why we were not getting signal, and even now I'm wondering, like, from the ethanol we could...
Oh, you don't know your number.
Okay.
Okay, now it's
So
right channel.
control time, and it's measuring the main issues. If I have to comment the challenges here, the contact problem might be there. So we always have to make sure it's connected well here, and here and here.
Yep.
And whoa, guys, we're getting something interesting.
So this is again a pure oxidation reduction.
Yeah, but it's super high.
Yeah.
What do we have here?
We have a port wood finish single malt whiskey from, I bought it in Finland. Distilled and bottled. Yeah. Tirenpilli Distillery, Lotti, Finland.
Yeah, so...
It has a similar profile, but not exactly,
Not
right?
exactly,
so the curves are quite different.
But we look here, we will look for the current, how high is the current, and we could calculate the concentration of the molecules present there. Also, we could measure some other parameters from here, like capacitance coming from here, and a couple of more. And it's different ring. And yeah, so usually what we do, we get this preliminary data and then we do reports, and later more deeper analysis. We would run different scan rates, for example, or different concentrations of adenolite to make sure we have what we have. And yeah, it's good control, I would say. We will overlay later what we have.
Yeah.
Next to the whiskey bottle in the lab is a bit suspicious.
But this is a nice thing, you know,
This is
to
also
compare
giving the same results.
That's why we are
Lithuanian
recording to make
monks
sure it's
to the
experiment,
Finnish
not having a party here.
whiskey. Yeah.
No, and what does it say? Does it match?
It's different completely.
The profiles are quite
Yeah,
different.
that's the
Yeah.
thing. We matched this we did. We ran. I will show you later.
Yeah, we can have.
Chromatographs, gas chromatographies, mass spectrums. They go stands completely on different opposite
Okay,
sides.
so we could explain using some mass spectroscopy what is happening here and compare to this technology,
Right.
which you can have right
Yeah.
here. You don't need.
So by the way,
bulky
what is the
experiment.
name of this technology exactly?
So the name of technology is called electrochemistry. So there's electrical process
Yeah.
happening and
Yeah.
chemical process.
Yeah.
When I was saying oxidation or reduction,
That's
that means
chemical.
chemical species are oxidized or reduced.
Yeah.
And we record electrical signal change, which is like voltage and the current in
Yeah.
this case.
Yeah. Yeah.
So shall we try one more liquid from my samples?
Yes.
Or two more? We have to. I at least have to finish at 3 because I have a meeting.
Okay.
Live meeting. So I have to. Shall I give you whiskey? This precious one?
Precious whiskey. This is from another archaeological find.
You know what I was thinking? Maybe gather. It's like we already have some data, very good, promising data.
But this
And-
is very different. This is going to be absolutely. This is herbal.
Okay.
This is very
So
different.
we might measure now if you have some.
Yeah, we can. Do
Also,
that
we can do
drops.
detailed experiments a bit later, right? But
Because she also has the sample she's going to take home and
Yeah. Can
continue.
you give me?
yeah, I will take a bit of another one.
Can you give me the pipette?
Yes, sure. These are tiny ones and it's perfect for the samples.
Okay,
For the
ready?
precious samples we have. So the measurement is done. I will save the data and we can start.
Can you just show me the export CSV file? I'm super curious what the.
Yeah, just give me a second. So this was your drink. How do you call
Yeah.
it?
You can call it Porti, P-O-R-T-T-I.
Yeah. Just to make sure.
Oh, it's amazing smell. No, it's like grass.
Oh my gosh! And what is this?
This is this whiskey, which is the oldest whiskey
It's oldest whiskey in Europe, maybe.
in the world.
In the world.
Reminds me the
Tell me
syrup.
Seriously?
It reminds me of the
Yeah.
syrup when you cough.
Wow.
Maybe. Yeah.
And how old is this?
the same. It's the same assemblage of bottles.
Okay.
One
it's from
seven-
1740.
1740. Wow.
Okay. I need a bit of ethanol just to clean it to make sure it's not contaminated from
sure.
there. Someone was giving me a hand with the ethanol.
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 So the CSV file must be what,
Can
like
you, when do you put the ethanol?
So
Before it evaporates, this one, no? What do you need?
I
You don't
need
need to take it out. So what do you need? Where? How?
I need to just clean a bit here and I have to be careful because we
The
have to make
set
sure
of
ethanol
electrodes
doesn't
for-
go to contact with
Ah,
very
okay. So
different.
when you okay, so
Before
you
I was
do it.
using pipette. Yeah.
They open.
Yeah, maybe you can help
Ah,
me
you
to
so you need to open it.
open. Do the same way we did before.
Did you get it?
Yeah.
Yeah.
It's right here. Perfect.
Ethanol wash, rinse.
Yeah. This step is important to clean the surface of the electrode. Whatever we had before.
Samples.
Yeah, you can search this a bit later.
A bit more ethanol.
Yeah, like that's it. I think it should be okay. It's like very high concentration ethanol. It evaporates fast.
Mm.
And now we are going to have sample.
All this is
Electrochemistry
Yes.
And is this
the
the-
branch of physical chemistry concerned with the relationship between electrical potential difference
You see?
and identifiable chemical
Also, it
charge.
has some color, so we might use.
This is the oldest whiskey
yeah.
This is the
sample.
oldest whiskey.
Nice.
Now,
I want these 3 images. I'm gonna put it on my on my desk.
Yeah, this is like a special
Yeah.
event
Let's try
for
to measure.
whiskey lovers, you
Yeah.
know.
People who like see.
And this one I think I would love to take away as well.
Yeah.
And
So
so
do you want to
Electrochemistry
use
of the
the
whiskies.
like
Yeah,
paraffin?
Porto.
Yes.
Oh wow, that's nice. So now you have 2 nice samples to analyze.
Yeah, I will analyze more deeper a bit later.
So Deep Scientific is getting into archaeobiology.
Bioarchaeology.
Oh my god! I'm so sorry.
Oh my, how dare you?
Because now since we
Bioarchaeology.
discuss our work, you know, I think for the more precise experiment, I would run ethanol measurement first, you know, to make sure it's all together. Then later, one sample, another sample. It just have to be optimized, the measurement itself.
Yeah.
Here. No, what does it say? But it's the same curve. I don't understand.
So it has to be
No,
similar,
it's,
but we will check
like, just
how the
minute
current is
difference.
changing. We will
Okay.
overlay, we will see better the difference.
Yeah.
It's always foxtail shaped.
But the overall redox reactions are going to be something
No,
like
what is
this.
the blue and red? What is the which kind of reactions that one? One is
It could be
oxidation.
more intense. Oxidation could be like very high and up.
Yeah.
If we would run some samples which can be oxidized easily, usually
So,
like iron
okay, can you
ions.
also explain like what exactly is an oxidation?
So oxidation is like the process, mostly chemical process. When
Like a,
oxidation
in
and
atoms, the
reduction.
adding of oxygen
When you are
molecules.
gaining electrons or losing
like,
electrons.
Yeah.
yeah, that's the
It's
thing.
explaining nicely
Yeah.
actually. So the labels are here.
But because actually here, the two you are maintaining the red and blue and green, right?
Yeah, but
three
these are 3 cycles, and maybe I didn't
like
talk
a
much
just now
here.
concentrating on
Oh, I see.
We
oxidation.
apply the voltage from negative 0.8 till 0.8 plus, and we repeat so in 3 times.
Ah.
So usually we want to see, the reason why I repeat, we want to see what's happening in the second cycle and third to say that the system is stable. Then
Okay.
it's
It's basically a
yeah,
repeated,
repeated.
file. I see. And the CSV files are separate for each file, or
Yes,
how do they look?
this is another topic
Yeah.
we can discuss
Yeah.
later.
Yeah.
You could export the data in such a way, you can script even here, you see the script.
Mhm.
You can,
Oh, analog view.
yeah,
So-
the way to analyze data is very like the way you like to be. It can be exported in the same file from different experiments, or it can be separated like exporting one by one. But also you can have like a coding by timing, having the gap between like, you know, you measure 1 minute, or you wait for 20 minutes, then you measure again, you repeat the cycle, you
Yeah,
can make
yeah,
the loops as
yeah,
well,
Yeah.
which is kind of
Yeah.
useful as well.
I mean, I think later on, I guess you can send these CSV files in our element research room, because
Yes.
then I can just download the raw CSV files and see how to actually ingest that into some kind of a, you know,
Yes.
distributed computing
Yeah, I
system.
think I will run more measurements for it. Also, my question would be how to call the second sample. So this was
But
the
that says 7.5.
7.5.
The archeologijos tyrimo centras 7. 7 tai yra medinio tipas.
Very good.
5.
Yeah. Because it's important to label well, because when we analyze the data, I make the script to take the information from the name of the
Oh yeah, file. Yeah,
file itself.
yeah. That's
Oh,
good.
where you are uploading it?
She's just downloading into her computer.
See,
After the software and the data she's downloading, the raw files.
I see.
Yeah,
Okay.
To the laptop.
yeah, to the laptop. Yeah,
Not to the
This
OneDrive or.
keyboard is like German keyboard.
and it's based on option. Yeah,
I mean, just a small file.
yeah, so, yeah.
Okay, this might work here. I save it for now, I will rename it later. So we want to overlay the data,
Yeah.
and
Oh, that's what you've done. You've asked the program. I guess the program has some kind of an analytics engine also.
Yeah, it has. I think that's why it's important to have a look into the program deeper,
Yeah, yeah.
what it can do, because I do believe we could optimize it a
Yeah.
bit.
But I guess you have a license to this software, right?
Yeah,
Yeah.
so for research, it's open source.
Yeah,
For
okay.
commercialization, we
Yeah.
might want to have our own
Yeah,
or
yeah.
use
Sure,
the license,
sure,
you know,
Yes.
which is doable as well.
Yeah.
It should not be difficult.
And it's a widely used software for this electrochemical sensing technology?
The software, it's not so widely used. There are plenty of different ones, but this
Okay.
is my favorite, and I think it's like user friendly as well.
Okay.
And powerful. You
Yeah.
can analyze
Yeah.
data directly.
Yeah.
So if I have to choose in between softwares that we
Yeah.
have present,
Yeah.
I think there are like almost 10 different companies.
Oh, okay. I
I would
see.
take this one.
Palm Sense.
Yes. Netherlands.
Netherlands.
Yes. I think I have.
No, so what do you see here?
Um,
Oh, so now you're overlaying.
yes, I'm just overlaying quickly the data. And how do I make sure I have all of these overlay?
Yeah.
Okay.
Nice.
Usually I take the first
Yeah.
scan out because we don't need much from there.
So that's the overlay of the unknown alcohol and then the Finnish whiskey from
Yeah.
today and the really old
Also
whiskey.
we'll add control maybe. The best control would be,
Oh,
I
wow,
guess,
look at that.
ethanol, but this is like really many things ongoing, and so this is
So this
just
is the
control.
ethanol control.
Yeah, we
That's
don't
from
have
your
any.
previous.
Yeah, the same electrode though
Yeah,
I did
okay,
measure
Okay.
previously.
Yeah.
And yeah, the control is right here. You see how tiny
Oh, wow.
current is
Yeah,
generated?
yeah.
Then
Can you
different
blow this
samples.
image or is that difficult? Can you make this zoom?
We could
Not
do
really.
what exactly we could do. Do you like this to be
It's fine. It's
wider?
fine. It's fine. I can see. That's good.
Yeah,
Okay. Right.
I think it's good enough.
And different electrodes are going to measure the same potential
Yeah,
versus.
it should be so.
microamps,
next
but
step
for
would
other
be
properties,
to
right?
repeat and measure more deeper. some
But
different
then by
properties.
the time it might appear evaporating, would be still okay.
I think it should be okay. It's closed. And how do you keep it usually? Does it have to be in a fridge or?
Yeah.
Okay.
I mean, I keep it so that's nothing that's gonna happen to it, like
Okay,
not
that's
that
good.
many activity.
Quickly.
Yeah.
Could you show the CSV file, please?
Yes. So
Because
since
that
we
would be
have
where I can.
all the data now here,
Yeah,
we
yeah.
could look for the options to export the data.
Yeah.
So these are the data, and we can
Yes.
use export data to
Yeah,
CSV
yeah, let's
file.
do that. Or it also
And
exports to MATLAB.
yeah, we
I see.
can say it as what do we say?
I don't know.
Something fancy.
Bioarchaeology.
Yeah, okay, good.
Bioarchaeology 0.
Okay, where's my German keyboard?
Single malt.
You see, it doesn't want to do it.
That's
Okay,
fine, that's
we'll
fine.
make an
Yeah,
error.
that's fine.
And when
Cool,
we
so
go
let's-
to the folder,
Yeah. And you exported all three now, right? The overlaid version, which is great.
it should be there. Like usually I name by the electrode and
Yeah.
the people that are there.
Mhm.
And this is the.
Oh, so you're
Ah, it
using
will open.
OpenOffice.
I
Okay,
think
Libre, that's great.
it might be
Yeah.
my computer, but usually you
Yeah.
might use Excel.
Sure,
So
sure.
what you get here, you get text
So
file.
it's semicolon
Yes,
separated.
and
Okay.
there's like one
Could we
column for
open it? So, okay.
voltage and
Yeah.
let's have a look quickly.
Oh, nice. Okay.
Yeah, and then later you might use Python coding to plot
okay.
it,
So there's
analyze
date,
it,
time, notes,
find the maximum, and so on.
But can you
Cyclic
give
volumetric
any
scan,
hint, like
1, 2,
what does
3.
it like actually
Nice.
say? What do you see from those graphs? What do you, by looking at it, what does it say?
So I barely can see, like there is a very strong oxidation and reduction process, but I really need to do more controls to understand which material is this. And usually it's based on the literature published, what we can see, and controls from the other samples, other drinks would be required to say more.
Yeah, but this we don't have adequate similar recipes, distillery practices, and might not have a modern reference. Then what?
Then I could talk about analytical parameters like how fast is the electron charge transfer and say how old is the drink. I think we could calculate this way, like
Really?
yeah, the age
They
or
should give you a Nobel Prize for that, like after Libby, Libby who invented radioactivity and radiocarbon dating. And
Yeah, Nobel Prize.
Learn University
second,
from.
and if you manage to date something from oxidation, that's fantastic. I mean,
I think that would be an option. A Nobel Prize sounds like dual, especially in this.
But now she knows the age. Now she already knows the age,
you
you know.
can tell me 1755. So the only thing what can tell us that accuracy is dendrochronology.
Yeah.
But this is liquid, so and 2 sigma radiocarbon dating is about 100 years variability, so it's not accurate enough for us.
Mhm.
So if you can tell us from oxidation, age, that would be amazing.
I think we just
It's
have to
possible.
work for it for a week
Yeah.
or so
Wow.
to get more data.
But so
These
you
are
will
very
have to
interesting
basically
samples.
work on it, and then you come back to us with some sort of new observation.
Yeah,
what
like
you
for
see.
example, I could make a report right now, whatever we have measured here. But as I said, the measurement is simple. You saw, you helped me, you did help with the samples and so on. But data analysis takes time.
Yeah.
Not time, knowledge.
But you know, this would be a great data set
Yes.
if it's okay with Giedra, because we're trying to build a curriculum, online curriculum for electrochemical analysis. So, but if Giedra is okay, then we can actually analyze these things, you know, as part of this material we're developing for students, right?
It has to be discussed, I think.
No, but the whiskey of my whiskey we can use for sure.
Yeah.
My whiskey and your ethanol is fine. That's enough for the
So
mathematics.
our plan is to make some lectures for like students, Erasmus students, and other people.
Yeah.
And we want
Yeah,
to use,
absolutely.
and we want to
I mean,
use
we
samples.
continue working on it. If it's
We want to
something
use
Yeah,
like
yeah, definitely.
food samples or something
Yeah.
like more
Yeah.
safe, like no one is going to.
Yeah,
be
yeah,
hurt.
exactly. Because this
Something
would be
you can
great.
find in the kitchen or somewhere else.
Yeah.
You know, I have the samples I sent to Max Planck, the liquids.
Yes.
They sent me back because we analyzed, we did some sort of aromatics, I think gas chromatography.
Mhm.
They told me, I mean, I have all those measurements. Yeah, but
Back.
if it's enough, because I have 5 liquids in total.
Yes.
5. You took 2. So I can give you all 5. I have them in separate small bottles that I sent to Max Planck. But
I
then
think
looked
this would be enough.
enough
Yeah.
for now. But these, we have 3 types of this kind of transparent ones, which they're very different from each other in terms of like the alcohol content and fragrance, preservation, and then one of this outlying whiskey sample, which you have.
Mm.
I guess if those 2 is enough, see what you can do, then can you tell, and then we can expand with the rest,
Yeah.
okay?
Yeah, because there are also many ways to prepare the sample. For example, we might want to evaporate alcohol and then use water instead of.
Oh, I
alcohol.
see. Make the
Yeah.
solvent
Yeah,
different.
or like
Yeah.
physiological buffers
Yeah.
and
Ooh.
measure it.
Right.
Find
so
exactly
tell me
what
if
is
you
there.
have enough, and this is for now, okay? Because
Yes.
I could give you more in the future.
Yeah, also we can keep it this as precious and do like we can develop methodology by using something else like
But for me, I'm not about much more about developing methodology. I'm more like about
She wants to
knowing
find out what
it is
happened.
and
Yeah.
what can you tell about archaeology from your
Yeah.
Yes.
methodology.
Ontology.
So you guys
did you
developing
say?
methodology.
Yeah.
And then later, when you develop that methodology, when you come to me and analyze those,
yes.
we can do separate project on analyzing.
Yes.
But I think, yeah, so we're in agreement that this data can be used for this coursework we're building, you know? So that, you know, like Erasmus Plus program.
Yeah, but this for that you can use more than liquids. Any of your booze you can use.
Yeah, let's just stick to the Finnish booze and the ethanol for our stuff
Because I don't want to experiment on some precious liquid,
Yeah,
something
that's
what we
true.
really
Yeah,
don't
yeah,
know.
you can
I
keep
would
it for
really already
research
want
and-
to
yeah, exactly. No,
Yeah,
that's fine.
this is a good idea
That's
of
fine,
yours. I
yes.
think to have something.
Yeah, exactly. So I just want the
commercially
CSV file
available.
for ethanol and this one
Yeah.
later, and then you can share it in the research room in Bakeworks. And then I'll write the libraries for ingestion into the big data distributed pipelines, right?
Yes.
So the future is that these sensors can be automatic, they can be collecting data in real time, and we can actually sense it, send it to some distributed system and do automated analysis, and people can help
And I think Pietro
take
is
actions.
asking very good questions, because what can I say? I can say with my bare eye what is happening, like something is happening, but to understand more we need to use AI or deeper analysis from mathematical point of view
Yes.
to compare what is exactly there.
You see, mathematics is good.
Of course.
Yes.
For the data representation.
I wish I knew mathematics
Oh.
more, to be honest. We are such a bad in math.
All right, I'm going to close. It's 25 minutes. Thank you very much, everyone, from the lab of bioarchaeology led by
Yay,
Giedre.
you nailed it.
Nice.